Welcome everyone in this next Pain in Motion masterclass. We had previous successful masterclasses from Mari Lundberg from Sweden, from Jackie Clark from New Zealand. We have several upcoming masterclasses, and today we have a very special masterclass as well from Felipe Reis from Brazil, from the University of Rio de Janeiro. Felipe has published widely. He's been very active. He's a very good scientist. He's not only a professor at the University of Rio de Janeiro, but he's also a visiting researcher at McGill University in Canada, and he's a visiting professor at the Vrije Universiteit Brussel with us here in Belgium. And Felipe is so kind to share his knowledge about artificial intelligence in pain research with us today. And so I'm very pleased that he's willing to do so. And Felipe, the floor is yours. I will now start sharing your screen, your slides.
Thanks, Joe. Thanks for this kind introduction. Sorry for the technical problem that we have in a few minutes ago. Good afternoon, everybody. It's a huge pleasure to be here and share a little bit about artificial intelligence in pain research. Of course, I'm not aiming to stress the topic and go so deep in some concepts, but I will present some definitions and also opportunities and challenges about the use of artificial intelligence in pain research. Next one. For those who don't know me, of course, I know many of you, but there is a long time that we met. I think that we met in 2018 during the IASP Congress in Boston. But I also know that the group is bigger than 2018, and someone of you doesn't know me. I have some research interests that we are working since 2010 related to pain. So we had produced some papers about education, especially about pain curriculum and implementation of pain curriculum, evidence-based practice curriculum. We are also interested in knowledge transfer, especially providing pain education tools. We are running some remote interventions trials, like we have the biggest telerehabilitation trial in Brazil. We also developed web-based interventions here. My main research interest is related to emotion, cognition, and behavior and its interactions with pain. And recently, I graduated myself in data science and machine learning. So in 2018, I came to the university bench, and started to do a new undergraduate course. So I graduated in data science and machine learning in 2022. So it's quite new for me as well, but it's very interesting, and I'm trying to apply all this knowledge on my research on pain. Next. So I have to declare that I don't have any conflict of interest to declare. Next. Well, we see a lot of news and also a lot of topics in magazines and also on TV about artificial intelligence, but we also see a lot of kinds of futuristic things about artificial intelligence, like very smart robots, smart cars, and etc. But we have a lot of internet, we have a lot of artificial intelligence things that we use daily. For example, Google search, quick reply, grammar check, image editing, fall detection, social media feeds, Amazon, Netflix recommendations, music and media streaming service, video games, chatbots, smart home devices, e-commerce, smart mail apps. So we have a lot of artificial intelligence based applications that you use every day. Next. What happened that make artificial intelligence so popular and so common in our daily lives? For example, this is a picture of a Soviet supercomputer from 1984. And this supercomputer in 1984, now it's less powerful than your smartphone. The growth of artificial intelligence is possible because the decreased cost of CPU, memory, and storage, the increase on data availability, the advent of big data, real-time data, cloud computing, and also Internet of Things, like smart devices. Next, please. I will start to present some concepts and then applications of artificial intelligence in healthcare, opportunities of artificial intelligence in pain research, and challenges that we still need to overcome. This is the overview of my talk today. Next. So this is these are some concepts that sometimes it's not familiar from some of you, like big data, artificial intelligence, machine learning, artificial neural networks, and deep learning. Sometimes people get confused with a lot of these different concepts. Next. So big data is a popular term that defines data sets that are too big to be stored and processed in a conventional relational database system. There are some V's that the literature presents to us, like 3 V's, 5 V's, 10 V's, but big data, some characteristics of big data includes a large data of a large volume of data, the velocity that this data is produced, a variety of data, and also the value of this data. So this is some characteristics of big data. Next. Machine learning is not new. It's begun in the 30s with, of course, with different types of machine learning. We usually to say that the first approaches of machine learning use a sequence of if you find this, do this, or if you find this answer, do that action. So this was the first line of machine learning experiments, and the father of machine learning is artificial intelligence is Alan Turing. He published his first paper in Computing Machinery and Intelligence, in which he asked, can machine think? And part of the history of Alan Turing is presented in this movie called The Imitation Game. The movie is about the Enigma machine that he developed to try to anticipate the German attacks, especially in UK. So the movie is very interesting to understand what they can do, especially trying to decodify some German messages. Next one. Artificial intelligence, machine learning, deep learning are subfields of computer science. But as you can see, machine learning is a subfield of artificial intelligence, and artificial neural network and deep learning is a subfield of machine learning. Next one. Artificial intelligence is a subset of computer science that has origins in mathematics, logic, philosophy, psychology, cognitive science, biology, and other sciences. In these pictures, you can see that artificial intelligence is the whole thing, and machine learning is a subtype, and deep learning is inside the machine learning, but we also have natural language processing. Natural language processing is some approaches that we can use to understand tests, to understand a speech, and also to develop some algorithms to interact with natural speech. So natural language processing, it's a subfield that has an interaction with machine learning and deep learning as well. For example, when you talk to Google Mini, or also when you talk to the Amazon device, we use natural language processing. Next. Machine learning was born from pattern recognition and the theory that computers can learn without being programmed. So machine learning has the characteristic that systems that learn without being explicitly programmed. The goal is to mimic the ability to learn through experience and achieving the assigned task without or with minimal external assistance. Next. There are some tasks that machine learning algorithms can be categorized, like supervised learning, unsupervised learning, semi-supervised learning, like hybrid methods, and reinforcement learning. Next. There are some differences, especially in supervised and unsupervised learning. Today, I will cover especially supervised and unsupervised learning. We are not talking about the reinforcement learning, but reinforcement learning is very common in development of robots, development of games, development of in cars. So there's a quite difference from the others methods of learning. But most common, especially for us in research, can be supervised and supervised, or the semi-supervised learning. So the difference between supervised and supervised learning is that in supervised learning, we have labeled data. What does it mean? When you have a spreadsheet, we know the outcome. Like we know if this patient will have chronic pain or not. So we have a classification. This classification can be numerical data or also categorical data. So in supervised learning, we know the outcome. And unsupervised learning, we don't have labels or feedback, but we are interested to search for hidden patterns. Next. So in supervised learning, we have classification that we can apply some algorithms to perform classification task, where the output variable is the form of distinct categories, like this is a patient with chronic pain, and this is a health patient, for example. And we have regression methods, where the output variable is in the form of numerical variables, like the level of pain intensity, or also the disability level. So we have a numeric output. And forecasting is related to time series, the method to make predictions based on the past and present data. For example, we are interested to understand what happened in the COVID pandemics, for example, in the next month. Next one. So this is a type of process that we do in supervised learning. So we have the data, we have a spreadsheet with some data. We need to define the objective, the data source, and we should explore the data, like understand the distribution of the data, understand the mean, the median. So we do a lot of exploratory analysis. And then some future engineering is necessary. For example, some algorithms need to be balanced before we present to the algorithm. Like if we have some algorithms that measure distance from a line, so we need to, for example, we need to normalize the data. The algorithm doesn't work so well if you have numbers so different. So we need to normalize the data, for example. And after we do all this pre-processing, we split the data in training data sets and test data sets. Sometimes we can split the data in 3 parts, but sometimes we don't have so many data to split in 3 parts. So it's usually to see that people split the data in 2 parts. Like the training data, we take 70 or 80% of the data to train the algorithm, and then take the algorithm and apply the test data, which means that we take the other 20% or 30% and show the algorithm and try to see if the algorithm perform well. And we also measure the predicted test data. In this part, we can have measurements like accuracy, ROC curve. So we can have a lot of measurements to see if the algorithms performs well. But this is the most interesting thing, because sometimes the algorithm is working very, very good with our data, but not so good in the real world. So I think that's the major problems with artificial intelligence or machine learning models. Is the validity, the external validity of the model. Probably because we don't have so many data that other science has. Next one. The unsupervised learning. Remember that unsupervised learning means that the algorithm doesn't receive labels for data. We don't know what's happening. For example, we can use here an example of customer segmentation. For example, we are trying to understand what people buy in a supermarket. So like we are interested to see, like here in Brazil, especially during the World Cup, people buy beer and people buy meat at the same time to watch the games and make some barbecue. So customer segmentations are kind of machine learning, unsupervised learning that can orient some marketing strategies. So there are 3 types of unsupervised learning problems. Association means that we are interested to discover the probability of the co-occurrence of items in a collection. Clustering, we are trying to identify patterns in our data. And dimensionality reduction can be achieved through feature selection and feature extraction. We are interested to understand what feature is very important in our model. Next one. This is a kind of supervised learning. We have some input data, and we present this data to unsupervised learning algorithms, and the algorithms try to split the data in different clusters, and they split the data with a specific distance between the clusters, saying that some data in that clusters belongs to that cluster, but not the only one cluster according to its distance to another cluster. So it's very important to use this kind of machine learning algorithm to understand like some profiles or also some pattern in data that we have, and we don't know the output, for example. Next one. Deep learning and artificial network. Artificial neural network was inspired by our brain. So they develop like biological mechanisms. And the fundamental unity of artificial neural network is the perceptron. Perceptron looks like our neuron, and the perceptron are organized in several layers. And the number of the layers means the complexity of the neural network that we have. For example, we have the perceptron here in the bottom of the down part of the picture. You can see some mathematical sequence there, and you can see the output. The input the data, pass through the perceptron, and he used a lot of mathematical numbers and expressions to get the output, and then pass to another layer. So as you can see, the organization of artificial neural network with some layers, we see that the input can pass through different layers and to have an output. Next one. Artificial intelligence network and deep learning, they are very useful for data that we call it unstructured data, like when we have tests, when we have images. So artificial neural network and deep learning works better than we have spreadsheets, for example. Probably artificial neural networks and deep learning can be used in these situations because there are much more data and complex data, and this kind of labels, different labels of perceptrons can produce a balanced output. So artificial neural networks is using to classify disease, using imagery, recognizing speech, translating digitalizing tests, and facial recognition. Next. So applications of artificial intelligence in healthcare. Next. There are a lot of opportunities to use also big data and artificial intelligence in healthcare. It's difficult to split the idea that machine learning is different from the big data because we need a lot of data to produce good models. So in healthcare, it's important to insert the idea of big data, but I know that's very difficult, and we will see a lot of challenges that you need to overcome. But big data and machine learning can be used for preventive care. For example, identifying people with diabetes that will develop diabetic ulcers, for example, studying drug efficacy, personalized medicine, identification and tracking patients, health trend analysis, enabling patients by informations, for example, presenting education or also presenting the knowledge specifically for specific patients, virtual care and wearables, and decrease healthcare costs. Next. There are some initiatives in physical therapy as well. For example, this is Kaya Health. Kaya is an app that tracks the motion of points on the body, used front-facing camera. An on-screen wireframe model guides patients through exercise, and proprietary machine learning algorithm evaluates patients' feedback and adapts the exercise program to the patient's need. As you can see, this kind of application use computer vision. It means that the cell phone can see what the patient is doing and provide some feedbacks about the exercise. And the Kaya Health was tested and presented in this randomized controlled trial and showed promising results, especially in the pain testing, 12 weeks when compared to the control group. It was made by exercise. Next one. Opportunities of artificial intelligence in pain research. Next. So when you search on the PubMed about machine learning papers, we have, since 2010, more than 70,000 results. And if we perform the same search, machine learning and pain, from 2010, we have 110 results. So the use of machine learning in pain research is quite new, and especially using clinical variables. It's very, very new, maybe because our data is not so big to perform good models. Next one. But machine learning can help us to answer some new questions, like what is the accuracy of artificial intelligence when considering brain imaging, patient-reported measures, physiological measures, biomechanical, behavior, and genetic tests. Can artificial intelligence differentiate or stratify severity and types of pain? Can artificial intelligence predict pain or chronification? Which artificial intelligence technique is the most accurate and why? Next one. So this is an example of machine learning study design. It's not so different that we do. We need participants with pain and participants without pain in the control group. Do some measures like questionnaires, neurophysiology, recording, functional imaging, and then apply machine learning algorithms. So this is a kind of, this is an example only of how can we apply or develop a study design using machine learning methods. Next one. This is an example that I brought. I tried to combine all the things that we saw during my presentation today. For example, what we want to do, if you like to predict categories, like doing classification algorithms, predict the class to which an item belongs, example, pain classification by its mechanisms. If you are using regression methods, pain intensity, trying to predict pain intensity or disability levels in the future, like taking some patients with subacute pain and trying to develop models to predict if the patients will develop chronic pain or also more intensity pain. Attribute importance, identify the attributes that most important in predicting a target attribute. Identify frequently occurring patterns and rules. Find items that tend to co-occur in the data and specify the rules that govern the co-occurrence, like treatment adherence. Identify the main characteristics to see if a patient adhere to treatment, like exercise or medical treatment. Discover groups using clustering approach. Segment demographic data into cluster and rank the probability that an individual belongs to a given cluster. Anomaly detection, identify outliers that do not satisfy the characteristics of normal data. Feature extraction, create new attributes like new features using linear combinations of the original attributes. And time series predict medication consumption, especially important for stakeholders, for example. Next one. There are some papers in the literature. These 3 papers, I think that they are very important papers to have an overview of the use of machine learning in pain research. And for those that are interested to read what have been done in the last years about machine learning in pain research, these papers can be very useful. Next one. Since 2019, we start to use some approaches in our research, especially doing secondary analysis. This is one of our studies. we try to predict the efficacy of the endogenous pain inhibitor pathway, comparing 5 different machine learning algorithms. So we compared the logistic regression, XGBoost classifier, decision tree classifier, random forest classifier, and support vector machine. And we identified the random forest classifier performed better with our data. But we understand that we have some limitations that probably this algorithm is working with our data, but cannot be generalized. So we will test with another sample of patients soon. But in the first paper that we submitted, we were very interested to understand what variables interferes more in our model, like widespread pain, sleep, the number of painful areas, the scoring widespread pain index, pain duration, fatigue, anxiety, physical activity, depression, and CSI with cutoff score of 40. These variables were the most influential in our model. Next one. This is another study. We ran a qualitative study. It was published last year in the Brazilian Physical Therapy Journal. It was about what patients think when they receive the diagnosis of low back pain. So we took the interview again, trying to see if there is a difference when people say about their experience in receiving the diagnosis of low back pain. And in the picture in letter A, we can see a patient with high level of pain and high level of disability and high level of education. In letter B, we can see a patient with high levels of pain and disability, but low level of education. So each circle, each red circle represents a word. So we can see that in the letter A, a patient with higher education probably develop and express their feelings about their pain with more details when compared to low education patients. And we also did the sentiment analysis, and 70% of the sentence were negative about the impressions about the diagnosis on low back pain. Some patients report a positive sentence and the others neutral sentences. So we are preparing this paper and probably we should submit it this year. Next one. So there are some challenges to overcome. Next. I specify some challenges, but not limited to that. For example, fragmented data. We still have some fragmented data, especially in healthcare. Appropriate security, data governance, who owns the data? The data is from the government or the data belongs to the patient. So there's a huge discussion about that. Machine bias, data ethics, what can the data be used for? Privacy, who can see my data? Metrics often do not reflect clinical applicability, as I said during the presentation. So external validity and generalization, it's very complicated with our current machine learning models. Logistical difficulties implemented artificial intelligence system and human barriers to artificial intelligence adoption in healthcare. Next one. So there are some home message. Sometimes machine learning's approach present the same performance of traditional statistical approaches. So machine learning is very interesting, but of course they have some limitations as well. Data science and machine learning give you the opportunity to deal with large databases with different types of data, especially, for example, dealing with tests, dealing with voice, dealing with imaging. That's traditional statistical approaches not possible to do. Machine learning methods open a window to ask new questions in the pain field. Clinicians and research may be aware that machine learning presents several problems that still need to be overcome. Next one. The next year, I will present with Anabela Silva, Rumi Parker. I don't know why they wrote Rumi Park. We'll be together in the World Physical Therapy Congress with this focused symposium addressing patients' need to using digital tools to enhance physiotherapy. So I invite you to join us in this focused symposium next year in Dubai. Next one. So this is our group, as we have the pain motion group in Belgium, we have the Pesquisa in Brazil. This group produces a lot of information to patients, a lot of tools to clinicians, and everything that we produce is for free. Clinicians or patients don't need to pay anything to use our resources. So thank you for your attention, thank you for your patience, and thank you for having me.
Thank you, Felipe. That was very clear. That's a very nice and robust introduction to the field of artificial intelligence and its application to pain research. The floor is open for asking questions, and there are two ways of asking your question. You can post it in the chat, or you can simply activate your microphone and camera, or without camera if you prefer it that way, and ask your question straight to Felipe. And before we while waiting for questions to arrive, perhaps I can ask a first one, Felipe. What's the weather like nowadays in Rio? Because it's getting colder and colder here in Europe.
Yeah, it's getting warm and warm here. It's very complicated right now. It's very, very hot. Yeah, but the weather is good.
Okay, you can enjoy the beach then, the nice beaches in Rio.
Certain.
Okay, there's a question from Jan.
Thank you very much. We have snow here in Denmark. It's very cold. So maybe Philippe, and thank you very much for a very nice overview and introduction to this area. Maybe you can say a little bit about what can you say, the software that might be available and how you start to work with these approaches with databases. Is that something that is fairly accessible to the average, can you say, skilled academic researcher, or is it something where you need to work with computer scientists in order to use these techniques?
Thanks, Jan. That's a very interesting question. I think that sometimes people is not used with artificial intelligence and don't want to try it, especially because they feel that they are not prepared to use programming things like Python or also R, and think that everything is complicated to use machine learning. But there are some softwares called no code. It's a family of software that we don't need to use any code. So like Orange is a software that we can use, and it's very good in types of everything that we can do, like all resources that we can do manually using programming. We can do on Orange that's much more familiar for some and much more friendly as well. So people can use this kind of software. And also there is another one that's very common. I forgot its name, but it's very, very common. There is a bird on that, but I don't use it so much because I prefer to use the Python language. Yeah, if you know to program, it can be very interesting because you can do everything you want with the data and present the data the best way that you think, like producing some graphics and also exploring the data. So using program can be good if you have time to learn, and but you can use some kind of no-code softwares, but there is a problem that have been criticized. That's a black box. So don't know what's happening inside the algorithm, and we are not so free to adapt something. So this is a kind of software, no-code softwares, but we can have some low-code softwares that we can do some things in the code. You can also produce everything using R or Python. That's the most used language. Yeah.
Thank you.
Another question from Ömer Elma.
Hello. Yeah, thank you, Felipe, for this really nice futuristic presentation, especially in pain field. But I have a question which you already mentioned as a kind of like challenge at the beginning of your presentation. As you said, in artificial intelligence, especially volume of the data is important to especially train the model, because you need to divide the data, one to train and then one to check the validity of the model. But in pain field, especially in medical sciences, we are not really able to reach to those kind of like the big volume of the data. And if we, for example, combine the data from all over the world, kind of like multi-centered randomized controlled trials, then some other confounding factors which can really mistrain the algorithm can play a role. So how we can overcome, especially, do you have any suggestions or ideas that how we can overcome this challenge? Because this is an important challenge when I think to implement the artificial intelligence in pain field, actually.
That's a good questions, Omer. I think that's the most difficult thing is to get the data, especially because in health we are not so good to share our data, and also to keep our data with us. Sometimes we use the data for a specific project, and then the data is not used anymore. So perhaps in the future we can plan kind of a standardized method to collect the data. So in the future, maybe 5 years, 10 years after we have a large database, then we can use. I think that multi-center study is a very interesting idea, and it's I think that we can plan. It's not so difficult to collect the data in different parts of the world. But for example, as you usually, we saw a lot of works with machine learning in using image, because like some diagnosis machine learning methods for cancer or something like that, because one image produces a large data set. And if you have, for example, 500 of images, you have a huge data set. It's different from clinical variables. If you have 500 patients, maybe it's not so big enough to have a good machine learning model that performed well. But it's interesting because sometimes we have good models with a small database. For example, this database that we explored about the pain inhibitory system, we had 300 patients. So it's not a big database, but we have 300 patients, and we explored. But in our paper, we presented that 300 paper is not enough to have a good model, and probably our model suffers a problem that we call overfitting. So it's like the model is so adjusted to our database that could not work very good in another database. So we collected more 150 patients with the same variables that were the model were not tested with, and we present this new data set to the model to see if it performs well. So in the first paper, we are more interested to show what influence our models to predict the pain inhibitory system. So I think that trying to collect more data, it's a good point, and sometimes using data sets that can be more powerful, like images, like speech. If you collect maybe 30 minutes of a speech from one patient, maybe you have a lot of data.
Yeah, thank you very much. Thank you.
Thank you. Thank you for the question.
Very relevant questions from Jan and Ömer, and also with, of course, together with the clear answers that Felipe gave, shed some more depth into our understanding of this highly innovative and new field for the field of pain research. So thanks a lot, Felipe, for the nice presentation and then the clear answers to these questions. Thanks everyone for joining us. In case you want to look at Felipe's lecture again, or if you want to recommend it to somebody, you can do so, because we will make the recording of this masterclass available on the Pain in Motion YouTube channel, and we will circulate it via our social media. And so again, thank you everyone for joining us today, and thanks a lot to Felipe for the presentation. And I want to finish up by making a little bit publicity for the, sorry about that, for the next master classes that we have planned. Here you see it. So next week, Wednesday, we have an online masterclass at 11 o'clock before noon on patient and public involvement in research from colleagues from the UK. Liz Groth and Rebecca Palmer will be presenting that one. And then mid-January, the 18th of January at 7 o'clock in the evening, we have another masterclass coming up on time point of adaptive brain changes in acute low back pain from Sabina Roots from Switzerland. So all very welcome to these masterclasses, and I wish you a nice continuation of this day. Thanks for being with us.
Thank you, Joe.